Hello my friends, my name is Ashkan and in today's tutorial I want to tell you 5 important facts you need to know when performing a pipe wall thickness calculation based on ASME B31.3 design code. Before everything, please like the video and subscribe my channel. Thank you my friends. Fact number 1. Pipe thickness calculation is presented for different conditions in the code: when the pipe is straight or when the pipe is bent or metered, when the pipe is under internal pressure, and when the pipe is under external pressure, and all of these explanations can be found in paragraph 304 of the code. Fact number 2. This is the formula that we usually use for pipe wall thickness calculation of the straight pipes. This formula is based on outside diameter of the pipe. The ASME code also introduces us another equation known as 3b that uses internal diameter of the pipe for thickness calculation. But what is common between the engineers is using equation 3a for thickness calculation. This is because the internal diameter of the pipe is a factor of the final thickness, and this makes the calculation more time-consuming because a loop check must be done during the calculation. Fact number 3. When considering 12.5% mil tolerance in thickness calculation, it doesn't mean to multiply the final Tm by 12.5%. We have to find a thickness that by subtracting 12.5% of that thickness, the final quantity doesn't come below the minimum calculated wall thickness or Tm. So, what is right is to divide your final quantity by 0.875. This will give you the correct final thickness. For example, assume that your Tm is calculated 10 mm. The wrong way is to multiply 10 by 12.5%, which gives you the thickness of 11.25. Now assume that you're the pipe manufacturer, and based on the standard, you're allowed to deliver the pipes in maximum 12.5% lesser thickness. Now, 11.25 multiplied by the mentioned mil tolerance would give us 9.84 mm thickness, which is below 10 mm or the Tm. So, the correct way is to divide the 10 mm or your Tm by 0.875. This gives us the final thickness of 11.42 mm, which won't go below 10 mm if the 12.5% of its thickness is reduced for the manufacturing errors. Fact number 4. The character C in this formula doesn't include the corrosion allowance only. If our piping is gonna be threaded and then used like the galvanized pipes, the required mechanical allowance equal to the groove's depth must be also considered. Additionally, if our piping system is intended to be used in services where sand or any erosive flow regime exists, an additional thickness is needed to prevent failure after some erosion in our piping. Fact number 5. In internally pressurized piping systems, sometimes we don't use exactly the design pressure received from the process department. For high pressures and high ratings such as 1,500 pound or 2,500 pound of ASME B16.5 or API 5,000 or API 10,000 of API 6A design standards, yes, it is correct to use the exact number presented by the process engineers. But the accepted practice among the engineers is to round up the declared design pressure to their maximum working pressure of the flange. For instance, consider that you have a carbon steel piping system with the process design pressure of 80 psi gauge. Your flange rating is 150 pound accordingly. In these cases, the piping engineers generally do not use 80 psig as their wall thickness pressure. Instead, they go to ASME B16.5 and find their material. There, you can find the maximum pressure that a 150 pound flange of that specified material can withstand. This is the pressure that we insert in the ASME B31.3 formula. You may wonder that what is the reason behind that? Please like the video and subscribe the channel to find out 2 reasons on this subject. The first reason is when performing wall thickness calculation, using 2 small design pressures would give us the thicknesses that makes the pipe vulnerable to construction impacts and pressures. This makes the welding also too difficult. The second reason is to make the whole piping system more integrated and homogeneous. Low ratings such as 150 pound or 300 pound are common in big plants and units. If you make different thicknesses for different design pressures, you will have diverse quantities of thickness in your piping system. In this way, you cannot use some pipes instead of others, and this makes your contingency too high. Now, by knowing all these notes, let's have an example. In our example, we want to find the thickness for an API 5L seamless pipe in sizes of 2, 4, and 6 inches. Corrosion allowance is 3 mm and the mechanical allowance is equal to 0. The process design pressure is 150 psi gauge and the design temperature is from 5 degrees centigrade to 100 degrees centigrade. Now let's go to the Excel sheet calculation and find the thickness. Okay, the piping class is not specified, the material is carbon steel, the process design pressure is 150 psi gauge, but as I told you, it is better to use the maximum working pressure of our flange and that rating, which is 19.6 bar gauge based on ASME B31.3. By converting it to psi gauge, the final quantity would be 284.2 psi gauge. The design temperature is 100 degrees centigrade here. Corrosion allowance equals to 3 mm. The allowable stress must be read from ASME B31.3 table A1, which is 20,000 psi as you can see. E or quality factor is 1. You can go to table A1A or A1B and find the details. Y is a coefficient from table 304.1.1 and is equal to 0.4. Melt tolerance is 12.5%. Mechanical allowance is assumed to be 0 because no specific information is received. And finally, the weld strength reduction factor would be 1 as our pipe is seamless. Okay, based on these data, the Excel automatically gives us the TM or the minimum pipe thickness. This number is multiplied by 12.5% and TP is obtained by now. The Excel sheet compares the final TP by the numbers in ASME B36.10 and gives us the thicknesses one step above the TP as the standard-based thickness. We also have one another rule in our pipe thickness design. We usually do not use the pipes between half of 1 inch to 1.5 inch below schedule 80. This is because of those reasons I mentioned previously. For pipes between 2 to 4 inches, it is better to use pipes at minimum schedule 40 thickness. And finally, for 6 inches and above, the minimum recommended thickness is 6.35 millimeters. Based on this, now let's select the final thicknesses for our pipes. Accordingly, the thickness of the 2 inches pipe would be 5.54 millimeter, although 4.37 is also acceptable. For 4 inches pipe, 6.02 millimeter is recommended, although 4.37 is acceptable. And for 6 inches pipe, 6.35 millimeter is recommended, although 5.16 millimeter is enough. Thank you everyone for watching this video. I tried to cover all the required information for the beginners and also those who are working for a while on thickness calculation based on ASME B31.3. To motivate me, please like the video and subscribe my channel. Thank you everyone and bye bye.